All right, we're going to start off with a little bit of review here about right triangles before we jump in tomorrow. So, as a reminder, a right triangle is any triangle that has a 90-degree angle in it. And it's usually marked by a square in the angle. So you've got your right angle here, and we put a little square down in the corner. All right, the legs of a right triangle are the two sides that touch the right angle. And the hypotenuse is the longest side. It is opposite from the right angle. All right, so this first warm-up says to label each of the triangles below. So first off, you have to check that it's a right triangle. This one is because of that right angle marking right there. So these two sides are the two that are touching that right triangle. So these are both a leg. And then this one, so across from the right angle, this is the hypotenuse. And we can do the same for each of these. So here again, I do have this little square in the corner, so this is also a right triangle. So the two sides that touch the right triangle, these are both legs. And then this guy across from the right angle, this is the hypotenuse. All right. Now the next one, it looks like a right triangle, but notice that it says nothing about any of the angles. These actually mean that those sides are the same, but it doesn't say that this right here is a right angle, even though it looks like it. So we can't label anything because we don't know that it's a right triangle. Same thing here. This one doesn't say anything. So I know nothing about any of the angles, any of the whatevers, not a right triangle. Now these guys, these do say something about the angles. It says that this angle right here is 63 degrees, and this angle right here is 27 degrees. Well, if you remember a little bit from geometry, I'm going to put an X down here in this corner. If you add up all the angles inside a triangle, you're supposed to get 180. So in other words, 63 plus 27 plus X, you're supposed to get 180. So we can use this to figure out what that angle down in the corner is. Well, to get rid of the 63, I can minus 63 from both sides so that these cancel. I get 27 plus X equals 117. I can minus out the 27 again. And that gives me X equals 90. Or in other words, that this angle down here is 90 degrees. Now, this is a right triangle. Even though it doesn't have the little square, 90 degrees is what makes a right triangle. So this and this are the two sides touching the right angle. So this is a leg and this is a leg. And then let's see, I'll kind of color code here. This side right here, across from the 90-degree angle, this is the hypotenuse. All right, for this last one, we're going to do the same idea. We have two of the angles. We need to figure out what the third angle is. So I'm going to put an X here. So let's see. If we add them all up, we should get 180. So minus out the 41. It gives me 46 plus X equals 139. Minus 46 from both sides. And we get that X equals 93. So this angle down here in the corner is 93 degrees. Now, this one is not a right triangle. A right triangle has to have 90 degrees exactly. This guy is not a right triangle, so we can't label anything in it. All right, and then let's change gears here, because hopefully this one should have been reviewed. So down here we've got simplifying radicals, and we did simplifying radicals in geometry, but that was a long time ago. When you see a number under a square root, and that's known as the radicand, we are going to make a factor tree. All right, so we'll do that in just a second. To make a factor tree, we are going to divide down by any prime number it is divisible by. Now remember, 1 is not a prime number until we break it down into all of its prime factors. So you are going to need a calculator here in just a second, but this little strip right here is going to be super important. These are all the prime numbers that you have to know about. All right. There's loads of prime numbers. There's an infinite number of prime numbers, but in our class, everything that we use is going to break down into either a 2, a 3, a 5, 7, 11, 13, 17, or 19. All right, so I've got the steps down here. So first step, break your radicand down into all its prime factors. So divide by 2, divide by 3, divide by 5, right? Figure out what it's divisible by. Step 2 says to rewrite all your prime factors in order. Number 3 says circle up pairs of prime factors. One of each pair comes out in front, and then multiply everything outside the radical together, multiply everything left under the radical together. All right, so let's put that into practice. So you're going to need a calculator out, because what we're going to do is we're going to start with this 96, and we're going to start dividing by prime numbers. Now, I always start with 2 until the 2's stop working, and then I try 3, and then I try 5, right? I just work my way down the list, and I think that works out best. So 96 divided by 2 gives you 48. Now, since 2 is a prime number, I like to circle it because I am done here, and we're going to keep going with 48. So I like to keep using 2 until it stops working. 48 divided by 2 is 24. I'm going to keep doing 2's. 24 divided by 2 makes 12. 12 divided by 2 makes 6. 6 divided by 2 makes 3. Now notice here that 3 is also a prime number. It's also on that list. So this is what we mean by break it down until everything, that whole tree, breaks off with the little prime number that got circled. All right, so here's what we're going to do now. I'm going to rewrite this radical using just these prime numbers. So it looks like there's 1, 2, 3, 4, 5 2's and a 3. So 2 times 2 times 2 times 2 times 2 times 3. So 5 2's and a 3. Now we're going to circle up pairs of numbers. So here I have a pair of 2's and another pair of 2's. This is not a pair of numbers because they don't match. So we're going to multiply together one of each type. So we're thinking in our head 2 times 2 makes 4. And then we're going to multiply up the guys that didn't have a pair. So 2 times 3 makes 6. And here's our simplified radical. So let's do the same thing for the next one. So 432. So same thing, I always like to start with 2's. So 432 divided by 2 makes 216. 216 divided by 2 makes 108. 108 divided by 2 makes 54. 54 divided by 2 makes 27. Now 27 divided by 2 is going to be a decimal. And so that does not work. So now that the 2's have stopped working, I'm going to try dividing by 3. 27 divided by 3 makes 9. 9 divided by 3 makes 3. And now look, they're all prime numbers. I couldn't have stopped anywhere else because none of these numbers are on our prime numbers list. So now let's go back and rewrite them. So 2, 2, 2, 2, 3, 3, 3. So 4 2's, 3 3's. So 2, 2, 2, 2, 3, 3, 3. Now remember, we're looking for pairs. So I've got a pair, and a pair. Remember that we multiply together one of each pair. So 2 times 2 times 3 makes 12. And then we multiply together everything that got left behind. Well, the only thing that got left behind was this 3. So the answer here is 12 root 3. All right, now let's try the next one. Now these next ones have variables in it, but that's okay. They work exactly the same. So we're going to start by still just making a factor tree for 50. So I like to start by dividing by 2. 50 divided by 2 is 25. 25 divided by 2 is a decimal, so the 2's have stopped working. The next number to try is 3. 25 divided by 3 also does not work. Now, remember, I'm using this list right here. So I tried 2's, it didn't work. I tried 3's, it didn't work. The next number I should try is 5. Well, 25 divided by 5 makes 5. So that is a really short factor tree right there. So let's write this big old radical. It's a 2 and 2 5s. Now here come the variables. This is x to the third, and that means that there are 3 x's. And this is y to the fourth, which means 4 y's. Right? And then the process is exactly the same. We're going to look for pairs. So I have a pair of 5s, I have a pair of x's, and I have 2 pairs of y's. All right. In terms of numbers, the only number that's going to come out is a 5. And there's 1 pair of x's, and there are 2 pairs of y's. So y squared to say 2 pairs of y's. And then under the radical, we're going to leave the 2 and the x. So it's the exact same process. It's still breaking it down and looking for pairs, even though it's got variables in it now. So let's try this next one. We're going to break down 100. So I like to start by dividing by 2. And I like to keep trying 2 until it stops working. 25 divided by 2 does not work. Divided by 3 does not work. Divided by 5 is 5. And so we're going to rewrite this radical here. So instead of writing 100, I'm going to write 2255. Now this says x to the fourth, so that's going to be 4 x's and 5 y's. 1, 2, 3, 4, 5. All right, and then we're going to try circling up pairs. So there's a pair of 2's, a pair of 5's, 2 pairs of x's, 2 pairs of y's, and that last guy doesn't have any pairs to go out. So we're going to multiply everything together. So 2 times 5 makes 10. There's 2 pairs of x's, so that's going to be x squared. 2 pairs of y's, so that's going to be y squared. And then everything left underneath the radical is just that one lonely little y. Right, go ahead and take a second to try these next 2 on your own. I'm going to pause the video right here so that you can try them out just on a separate sheet of paper if you need to. And then when you hit play, it'll have the answers up for you. All right, and here are the answers to them. You can tell I kind of ran out of room here. But 2 2's and 3 3's. Now, if your factor chart looks a little bit different than mine, that's fine. You'll still wind up with 2 2's and 3 3's no matter how you did it. And then over here, it was just the numbers. There were 2 2's, 3 3's, and a 5. And there weren't any variables, so I didn't have to write any x's or y's down there. All right, from here on out, the right triangle recap, practice number 1 is on edge elastic for you to try on your own.